And welcome back as we go ahead and get ready to dive right into talking about generics. We have a lot to kind of really dive in and pick apart this lesson, so let's get started. The first thing we need to understand when we start looking at generics and classes of similar things is type parameters. Classes and methods can have a type parameter. The type parameter may then have any reference type and hence any class type plugged in for that type parameter. This plugin would then produce a specific class type or method. For example, if we look at this code here, we'll see a very simple definition with the type parameter t. And t, of course, is simply referring to that type parameter. Now, all type parameters typically have an identifier. You can use any non-keyword identifier for the type parameter. You don't have to use t. You can use anything you really want. However, by convention, type parameters start with an uppercase letter, and there's some tradition using a single letter for a type parameter, as we just noticed we had type t. Starting with the uppercase letter makes sense because typically a class type is plugged in for that type parameter. And because we are creating parameters, we then lead this to making full-on definitions. A class definition with a type parameter is stored in a file and compiled just like any other class. For example, the parameterized class shown on the previous slide would be stored in a file named sample.java. Once that parameterized class is compiled, it can then be used like any other class. Except for that when you're using your code, you have to specify a class type to be plugged in. So if we look at an example here, we have sample class string. That's what we're plugging in for t. Object1 equals new sample string. And of course, then we do some set data down here. Then we can get the data. We can, of course, also do like a pet object. So if we had our pet class that we've done before, you can see here that we can create a pet class. And of course, then we can do some code and we can set it as well. So everything that we expect to do with our normal classes, whether it's accessors, mutators, doString, equals, all those sort of things, can still happen. It's just now it's a parameterized class. And again, it doesn't have to be something that's already existing. We can create our own classes and parameterize them. Now, anytime we get into working with parameterized classes, we do need to instantiate them. So if we look at sample string, what we're doing is we're obtaining from a generic class by plugging in a type for the parameter that's said to initialize that generic class. So in this case, that type that we plugged in was string. So for example, sample string would do the generic class for sample because, again, this is the class that we're plugging in. This is simply just the type that's being plugged in for it. You'll notice the angular bracket notation for the type parameter for the class type that's being plugged in for that type parameter. Now, starting in version 7, Java supported a feature called type inference, which means Java can infer the base type and the call to the constructor based upon the base type that's used within that variable declaration. And what this ends up meaning is that if I were to look at the kind of structure, class name, base type, object name equals new class name, base type, blah, 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 we could write this out as class name, base type, object name equals new class name. Notice the base type that was here in these brackets is no longer here in these brackets. So this is inferring what that type is. So if we look at that with two actual examples, for example, array list string list equals new array list. Notice we don't have anything inferred here. All right, we don't say that that is a string because Java is going to infer, oh, you want to use a string, and so you don't have to write that here. Same thing if we look at this with array list double, you'll see the same thing here too. And of course here we do specify how big this list is, but that doesn't actually affect the inference. Now, this new format does save us a little bit of typing and is a little bit cleaner to read because we're not seeing the extra string kind of thrown in there. However, many people have been using that previous format, so you're very likely to see that in existing code if you ever come across it. Now, let's look at an example here with our different type parameters and everything. We're using something for ordered pairs. In the generic pair demo that we'll look at here in a little bit, we've been given a parameterized class for ordered pairs of values. You'll notice that the constructor heading does not include type parameter t. The constructor instead can use a type parameter as a type for the parameter constructor, but the constructor heading does not include the type parameter in angular brackets. So that's very important to note here. By using the parameterized class with the type string, which is then plugged in for a t, we can get a class whose objects are pairs of string values. So for example, we have pair string, so you can pair equals new pair string happy, comma, day. And if we were to look at this with the integer, all right, we'll get a class whose objects are pairs of integer objects. So looking at this real quick in Eclipse, you can see we have our pair class here, which is simply just a very basic class. And you can see we have our T right here. So that's a very common letter that we're using to represent that. And you can see it also is here in our constructors, as well as being the type here in our private variable. So first and second, we're not necessarily specifying what it is because we could do different types. So if I look at my generic pair here, you'll see we have pair string here, which of course is passing it in a string. But then later, if we do this, we can look at the same thing with, for example, integers. We can do that same kind of thing. And we're going to look at that here in a minute with our two pair demos and stuff. But you can see very quickly and easily, like just because I said, hey, you know, this is type T here, but now we're going to replace that with a string. Awesome. It gives us a lot of power and flexibility to be able to do such a construction. Now, there is one pitfall for us to kind of be aware of first off, and that is that a generic constructor name has no type parameter. A class name in a parameterized class definition has a type parameter attached, such as pair T in our demo. If we look at that demo, you can notice how that was actually constructed. And that might mislead you into thinking, hey, I can use this type parameter heading of a constructor definition. But we actually don't need to repeat that type parameter in the heading of the constructor definition. So we would just use public pair, not public pair T. All right, so it's very important that we kind of make that distinction when we start looking at that. A constructor can use the type parameter, such as T, as the type for a parameter for the constructor, but that constructor heading does not include the type parameter angular brackets. So if we look at that, we'll see public pair, T first item, comma, T second item. Notice that angular brackets with the T is nowhere to be found in here. So very important distinction to make sure we do that, otherwise we're going to run into errors. Now, a generic constructor name, like I said, has no type parameters because it might seem confusing of how this can be done. And I don't want you to lose sleep over it because as we noticed, the definition of parameterized class, the constructor has no type parameter in the angular brackets. All right, and again, public pair, T first item, T second item. And if we look at the demo, again, when we took that generic class and we specified what type we wanted to do, all right, you do specify the type in angular brackets when writing the constructor name. So pair string, secret pair equals new string pair happy day. However, this second case is not hard to remember because if you leave out the word string here, Java's not going to know what pair class are you referring to. The compiler would not tell you if you meant string or double or any other kind of type that you want to put in here for this pair. The other pitfall to kind of be aware of is that you cannot plug a primitive type in for a parameter. We should kind of expect this one because we've seen this with array list. Remember we said array list can't have a array list of ints or doubles or something like that. We can use the wrapper classes, but we can't use the primitive types. Now, we do know that Java has automatic boxing, so this is not as big of a restriction as you might think, because again, we have the wrapper classes, so we can have integers and we can have doubles, because we can still pass in an integer value without trying to make it into a class value, because Java is automatically going to box and unbox those values for us. If we want to say, hey, how can we get this pair class to work? Well, let's go ahead and look at the generic pair 2 demo to kind of get a good look at that, because that's going to really kind of see, hey, well, we saw how it works with strings. How do we do this in integers? Well, this is very typical when we want to have a type parameter that's a class type. However, just remember, if you plug in any reference type, you can plug in an array type for a type parameter. All right, so if we look at generic pair demo 2 here, you'll see it's very similar to our first one. So I'm just going to put these side by side real quick here. You can see they are almost identical in how they implement things, except for this is, of course, taking a string. This is now taking in an integer. However, one of the things you'll notice is that when we are getting our inputs, this is a string, which is a class type, and this is an int, which is a primitive type, and we're using keyboard.x int. Again, it is not something that we have to worry about, even though this is an integer that's being passed in here, because Java's handling that automatic boxing and unboxing of those values. Now, the other pitfall to be aware of is that a type parameter cannot be used everywhere that a type name can be used. With the definition of a parameterized class, there are places an oriented class name would be allowed, but type parameters are not. For example, you can't use a type parameter in simple expressions using the keyword new to create a new object. So the following would all be examples of things that are illegal. So T object equals new T. All right, that first T part there is illegal, and the second half of that is legal. All right, because this is technically specifying it's this type of object, but T doesn't exist as a class type, it's a type parameter, so this doesn't work. And with here, we get the first part of this is legal, second part is illegal, because here we're specifying as an array. Great. And this is saying new T10, again, not going to work because this is, again, using a type parameter instead of a class type. Now, this restriction may not be as arbitrary as it first appears. So for the first example, T is not being used as a type name, it's being used as a constructor name. And in the second case, T is being used something like a constructor, though it's not officially a constructor. But these are still things to kind of be cognizant of when we go write our code, because obviously we could run into errors. Now, an instantiation of a generic class cannot be an array base type. So this is a little bit of a thing to remember. Arrays such as the following would be illegal. So pair string array A equals new pair string 10. This is illegal. All right. And while it might seem like a reasonable thing to want to do, it's not allowed in our code because of the technical details that have to do with how Java implements generic classes. And the full explanation of why this is going to be on the scope of what we handle in this course. So just understand for now that this is not something that we can really handle within our coding. Now, I do have a tip for you, which is that a class definition can have more than one type parameter. A generic class definition can have any number of type parameters. You can have multiple type parameters that are listed in angular brackets, just as a single type parameter case, but they're separated by commas. Now, to see this, we're going to rewrite the class pair, so the first and second items in pair can be different types. And in our two type pair demo, we've given a very simple example of using the generic class with two type parameters. So if you look here, here's our two pair, and I'm just going to bring pair right over real quick just so we can compare these two classes. You'll see that these two classes are not drastically different from one another. The biggest things, of course, is that this is pair, this is two pair. Things haven't, again, drastically changed between them. However, where they get handled now is because of how this is set up. If we look at our demo, we can now pass in two different types. All right, so here we see type 2 pair. We have a string and an integer being passed in, and that allows us to pass in two different types in here. So when we look at this, you'll see, for example, we are able to bring in a string value, and then we're also bringing in an integer value. So it's pretty cool. So we have down here some values that we can get in here, which, we have a .next int, awesome, rating.get first, rating.get second. And that's, of course, all different things that we are kind of really pulling from when we look at how this is actually constructed here. For example, we look here, here's a bunch of different things that allow us to really construct this class the way that we would hope that it could be constructed here. But again, this is the biggest difference here is that this is using two parameters versus we look at, like here when we had generic pair, we had one parameter type. Now, one other thing I want to point out is that generic class cannot be used as an exception class. If you try to begin exception class definition files, you will get an error message, public class by exception T extend its exception. It's still illegal, even if you try to say, well, I'm just going to replace exception with error, throwable, or any other descendant class of throwable. All right, it's not going to work. And that's because you cannot create a generic class whose objects are throwable. Now, on top of that, we also have to understand that there are bounds for parameter types. You can't simply just have them be whatever you want. Sometimes it does not make sense to plug in any reference type for the type parameter in a generic class definition. So if we look at the class pair, let's say we want to add a method that returns the maximum of two elements in an ordered pair. Well, we could try to add this method definition, public tmax, if first compared to second is less than or equal to 0, return first, else return second. Well, notice in there we're using the compare to method. All right, and what the compare to says, like, well, if I use compare to, it has to implement the comparable interface. And if we have the comparable interface, well, we remember this is a standard Java interface that we discussed back in our programming 2 materials. And recall that it only has the following method heading that has to be implemented: public int compare to object other. So then when we define a class that implements the comparable interface, the programmer is expected to define compare to so it returns either a negative number if the calling object comes before, a 0 if the calling number equals the parameter, or positive if it comes after the parameter. Now you can start seeing how this can come into play, and of course when we have things like our keyword extends here, this all works great except for one minor problem. All right, the type parameter t might satisfy the comparable interface, but remember, Java allows you to plug in any type for T. So any type parameter can be plugged in there. And while you can have Java enforce this rejection of possible types that can be plugged in for T, the way to do this is ensure that classes that implement the comparable interface that are plugged in for T begin the class definition as follows. Public class pair T extends comparable. So we're taking that T type and having it extend comparable. Now the part that extends comparable is called a bound on the type parameter T. Now if you attempt to plug in a type for T that does not implement the comparable interface, you will get a compiler error. All right. Now note that when we use the keyword extends, not the keyword implement. All right. So it's very important here because this is an extending. So just like how we see like our derived classes, for example, we would see T extends comparable here. So it's just a little bit of a different thing we might be used to. But in here, when we want to put this bound on, we can say it extending that interface. And of course, then any class that you're plugging in for this would have to extend to include that interface. Now, when we look at these bounds, the bounds that extends comparable is not just an optional thing for us to make things work well for us. Because if we take that extend comparable out and we try to use those methods that we want to do, we're going to get an error message saying like, hey, I don't know what you mean by compare to. What are you trying to do here? Well, a bound on type may be a class name rather than interface name, in which case only descendant classes of the bounded class may be plugged in for those type parameters. So then the following that would be only descendant classes of, for example, employee may be plugged in for T, where T employees of a class. Let's say public class, same generic class, T extends employee. And this, of course, can lead us to wanting to say, like, you know what, maybe I need multiple bounds. Can I do multiple bounds? Well, this is why we want to use the keyword extends instead of the word implements. Because in order for us to do this properly, you can have, let's say, multiple interfaces and possibly one class within that bounds expression. So if we say like public class, another generic class, T extends employee and comparable. So it's using both classes here. If you have more than one type parameter, of course, the syntax is as follows. Public class, yet another generic, T1 extends employee and comparable, comma, T2 extends comparable. So this is where you can start putting in more than one type parameter. Pretty awesome. And you can list any number of interfaces within a bounds expression. However, you may only list one class. And so if you notice up here in a previous one, what is that class that we used? We used employee. We did not use comparable here as a class. It was an interface. Moreover, if you do list a class in some interfaces, remember the class has to come first within a list. If we look here, employee is first. So it's very important that we make sure we put the class in there. Remember, an interface can have more than one type parameter. And the details and notation for those interfaces are going to be the same as the classes for type parameters.